I'm Yuchen Zhu, and in about 4 minutes, I'll introduce our churn prediction project for MTN Nigeria and focus on what I personally improved to make the model realistic and useful. So our goal is to predict which customers will churn and turn that into actionable and retention strategies. And so the next slide is I'll give a quick context, then jump to my key contribution, fixing data leakage and build a future model. So churn means customers terminate service in telecom. Retention is critical because acquisition can cost many times more than keeping exiting customer. So in the next, Nigeria is Africa's longest telecom market with strong growth. So churn management has real business impact, and churn risk that is affected by uneven coverage and policy constraints, and customers are highly price sensitive, and pricing and plan mismatch are direct triangles. Which user feel plans are too expensive or don't fit usage, they switch to the competition. And let's go to the slides 27. Yeah, after pre-processing, the overall churn rate is about 30%, and two reasons: high call traffic and um, competitor attractions account for over 60. So the key question is, can we predict churn before this after the fact reason appears? So when the let me check 31, yeah. So when we first modeled the data, we saw accuracy over 90 that looked great, but it was suspicious. Interim prediction results that perfect often mean that model is used information it shouldn't have data leakage. So I checked the feature and found leakage. Feels like reason for churn, and scoring feels like R score, F score are essentially post-event information. So I removed those leaky variables and dropped the non-informative IDs. Performance become more realistic and the model become deployable. And then I rebuilt pre-processing as a constant pipeline, encoding categoricals and scaling numerics. So train and test processing accessingly. And then we use the three complementary models: logistic regression for interpretable baseline, random forest for non-linear patterns, and gradient boosting for strong predictive power. Then I forced them with soft voting, averaging predicted probabilities to improve robustness and catch more returns. So let's go to these are reference, and let's go to the 38. We evaluated with multiple metrics, not only accuracy, because churn is imbalanced and recall matters. And the 44 slides shows after improvements, AUC reached 0.76, showing more reliable discrimination, and F1 improved significantly, means a better balance between catching churns and avoiding false alarms. And two actionable insights. First, low value customer have much higher churn. They are a large share base, so small improvements created big impact. Second, new customers are the critical window. Early retention in the first month matters most. So the improved fusion model provides practical tools for targeted retention and insight supports segment strategies. So that's all. Thank you.